My name is Manuel Rodriguez Gonzalez and this is my oral exam. For question 1, the chromatography process I propose for the purification of beta-carotene is liquid columns chromatography using a stationary phase combined with a non-polar solvent such as ethane or acetone. This choice is based on the fact that beta-carotene is a non-polar compound which facilitates the disruption of cell membranes and the subsequent stretching of the carotenoid. To scale up the processes, chromatography scale-up principles must be followed. The scaling is based on the diameter of the column using the following equation. This equation is related to the following one, where Q1 and Q2 values are the flow rates at laboratory and industrial levels already known, thus obtaining the scaling factor. Knowing the scaling factor, the industrial column diameter can be calculated using this equation. Finally, the length of the new system can be determined by rearranging the following equation. Additionally, Darcy's equation must be considered to estimate the pressure drop across the column under the new conditions. For question 2, several strategies can be used to monitor the carotene purification process. One is FTIR, Fourier Transfer Infrared Spectroscopy, which is fast, non-destructive method that can recover the sample and detect characteristic functional group of carotenoids. This technique involves placing a small amount of the sample into the device, which emits infrared light and different wavelengths to detect molecular characteristics. Another effective technique is HPLC, High Performance Liquid Chromatography, particularly with a C18 reverse phase column, which is suitable for carotenoid purification. Carotenoids are detected with a UV bead detector at 450 nanometers, and if a peak appears in the chromatogram around 25 minutes, this suggests the presence of carotenoids. Additional peaks at other retention times may indicate contamination. And finally, for the question 3, to scale up an ultrafiltration process for an U fluorescence protein such as GFP, several factors must be considered. Ultrafiltration involves selecting a membrane with a molecular weight cup of MWCO between 10 and 30 kilodaltons, which is used during the filtration to separate proteins based on size. Before scaling up, a small-scale characterization must be performed to evaluate GFP, recovery and retention using the target membrane. The process begins by calculating the permeate flux using the Nets equation, where G is the permeate flux, P is the permeate volume, A is the membrane area, and T is the filtration time. Once optimal operating conditions are established, the system is set up with suitable pump and pressure controls. The process proceeds with concentration to reduce volume and increase GFT concentration, followed by filtration to remove salts and impurities. Scale-up is performed using the following relationship, where A1 and B1 are the membrane area and volume at lab scale, and A2 and B2 are the corresponding scale-up values, which the new permeate flux and filtration time can be calculated and used to assess the performance of the scaled process. Finally, several key conditions must be taken into account, such as avoid excessive pressure that could damage the membrane or prevent exposure to light, as GFP is photosensitive.